Explain how linear, quadratic, absolute value, and exponential functions are similar and different when transformed. You've been doing linear since at least 7th grade. Quadratic we learned this year. Absolute value we learned this year, and exponentials we learned last year. Okay? Oops, I'm not on the writing tool. Okay, show me with your arm, please, what does a linear graph look like? Straight, right? It's a line. Something like that, right? With arrows, it goes on forever in both directions. Okay, show me what a quadratic looks like. What does a quadratic look like? Yep, a U, right? So some people are kind of doing like a football thing, U, cupping it. Great. Okay, show me what an absolute value looks like. It's different than quadratic, right? Should be a very sharp V. Oh, you can just do that with your fingers, yeah? Straight arms versus the quadratic or curved arms. Quadratic is curved at the bottom. Absolute value comes to a sharp point. Okay, we'll do exponentials in a minute. Okay, each of these have what's called a parent function, the most basic function, the most basic way to write each of these functions. Let's start with quadratic. Who can tell me the parent function of a quadratic? Oh, that's the quadratic formula. Related. It starts with y equals, though. Annabelle?
Y equals -x squared.
Positive. But close, yeah. That's the most basic function of quadratics. Y equals x squared. Okay, who can tell me the parent function linear? Most basic way to write a linear function. McKenna? Okay, that is the formula for slope-intercept form. You guys are funny. You remember the formulas, which is good. It's just y equals, what lets me know it's linear? X. X to the first power. X to the second power lets me know it's quadratic. Okay, what's the parent function for absolute value? Y equals, what lets me know it's absolute value? Maybe I should have absolute value signs? And what goes inside of it? X. Okay, those are the most basic ways you can write each of those, and they're called the parent function. From the parent function, there's shifting that happens. Okay, linear doesn't necessarily have, I'm just going to put, we have our A, we have the X, and I'm just going to put plus K. Putting a plus or minus H inside X really just affects the vertical shift. The vertical shifts and the horizontal shifts kind of are intertwined in linear. But quadratic, we have the AH and K. Y equals A times the quantity x minus h squared plus k. Y equals A times the quantity x minus h squared plus k. Absolute value also has the AH and K. Y equals A absolute value of the quantity x minus h absolute value squared plus k. Get notes out, please. Do quadratic and absolute values look the same? I need a new piece of paper. Do they look the same or nearly the same? I think there's only one detail that's different. To me, they look the same, except for one detail. What's the detail? Parentheses versus absolute value. So you can see they all have an A, quadratics and absolute value both have a possible horizontal shift, and they have a vertical shift. Okay, so what does this K do? All three of them have a K. What does the K do to the graph? Vertical shift. So let's go through and put VS on all those. VS, VS, VS. What does the H do to the graph? Horizontal shift. Basically, if it's contained within the function, in the grouping, again, absolute value can be a grouping, it's a horizontal shift. And we have a saying, if it's inside the grouping, what do we say? Opposite. If it's outside the grouping, we say same. So what goes with this one? Just the same. Opposite, same. Opposite, same. So this should all be familiar. And then the A, when we actually just did the homework review problem, we wrote down everything we needed to know for the A. So let's put it on these notes. No matter which function we're doing, A has three things that could happen. If A, the absolute value of A is greater than 1, we just did this, what happens? If you go like 2 is greater than 1, up 2 over 1, up 2 over 1, what happens to the graph? Well, it increases more than it goes out, so that was a vertical, not shift, vertical stretch. So it's getting steeper, the arms are coming in. Vertical stretch. It gets steeper. This applies to all of the A's, this A as well, and this A as well. So that's when the absolute value of A is greater than 1. What happens when the absolute value of A is between 0 and 1, such as fractions or decimals that are between 0 and 1? 1/2, you go up 1 over 2, up 1 over 2, up 1 over 2, up. It's a compression because I'm going wider. When you compress something, it oozes out the sides. That's a vertical compression. We're going to get wider. Okay? And the last thing is if A is less than 0. No need for the absolute value sign because if you do the absolute value, we can't do be less than 0. What happens if it's negative? It flips about the x-axis. Hayden, 12 p.m. Okay, he's in the back. Will you wave your hand? Okay, it flips. Okay, so I'm going to go through a few examples and explain what has happened to the graph, or what has happened to what the translations are. Translation is another word for shifting. Okay, does anyone still need time to write these down? Okay, then example 1. How are y equals 2x and y equals 2x minus 3 related? And how are their graphs related? How are y equals 2x and y equals 2x minus 3 related? And how are their graphs related? Do you need a real pencil? Okay. What's the difference between 2x and 2x minus 3? Minus 3. What do you think minusing 3 does? Okay, hold on. That seems sturdy now. This one's a crappy pencil. Okay, maybe. I don't remember whose was whose. Here's 2 pencils. Hopefully they don't break. And I lost my marker. Okay. What happens if I plug numbers into each of these? What do I get when I plug 0 into this? No, because it becomes 2 times 0. 2 times 0 is 0 versus this one, if I plug in 0, what do I get? -3. Interesting. Okay. What if I plug in 1? What do I get here? 2, because 2 times 1. What do I get here? So what's happening each time? These are not giving me the same numbers. 1 is always, this one is always 3 lower. So that's something that's how they're related. Y equals 2x minus 3 has outputs that are always 3 less than the outputs of y equals 2x. I guys write that. I set my papers down. I was sharpening those. Here they are. Okay, that's how the equations are related, and maybe you've already determined if we graph these, 2x's are the same, but this -3 is after the x. What type of shifting or translation, that's another word for shifting, what type of translation is -3 if it's after the x? So vertical, but does it go up or down? Down, because we say same here. So for the graph, how are their graphs related? They have the same shape. The graphs are the same shape because the slopes are the same, 2 and 2. And they're both linear. They're the same shape, but y equals 2x minus 3 has a vertical shift down 3 units. I like to have those 4 words. Vertical shift down 3. 4 words when you're describing those shifts or those translations. That would be the answer to explain how they're related. Does that make sense? I don't think we've done anything too new yet. Okay, another one. Example 2. For the function y equals x minus 4 all squared, identify the translation from the parent function. Okay, from the function y equals the quantity x minus 4 all squared, identify the translation from the parent function. So first you have to know what the parent function is. Raquel, do you know what the parent function is? So we have the 3 at the top. It's one of the 3 that we put at the top. Is this linear? Is it quadratic? Or is it the absolute value? It's quadratic. So what's the parent function of the quadratic that we wrote down? Y equals x squared. So that's the most basic way we can write a quadratic. Okay, but this one has an extra detail. This one has been changed a little bit. What does our new function have? It has a number, doesn't it? Minus 4. It's inside the function. Would you turn to your neighbor, please, and talk about what translation it is? You should say 4 words. Translation means shift, which direction it goes, and how many units. You should say 4 words. What is this? What does that do? Just 4 words. Hey, you said 6 words. You said 5 extra, too. Okay, 4 words. And you have to know if it's opposite or if it's same. All right, who knows that their neighbor knows it? Really? Fernando? Okay, Fernando, what 4 words do we have? Okay, the vertical shifts are outside the function. Oops, whoa, that's weird. Go away. Okay, see all the vertical shifts, how they're, hey, look this way. See all the vertical shifts? How they're after the absolute value, or they're after the parentheses? What's inside the grouping? Opposite, and what's shifting? It's not up. No. HS. Horizontal shift, but if it says minus, it's not up. Your options are right and left when you're going horizontal. But it's opposite. The negative numbers are to the left, so we go right. Whew. Horizontal shift because it's inside the grouping. Right 4. Horizontal shift, right 4. Because it's inside the grouping, it's a horizontal shift. Your only options for horizontal are right and left. If it's outside the grouping, it's a vertical shift, and those options are up and down. Okay, I think we need to practice one of those. Let's try another one. We'll just do this as part B. I'm going to do the same thing, and all you have to do is, in 4 words, tell me the translation. Y equals x minus 2 squared plus 5. I lied. This one's 8 words. Why am I saying it's 8 words now? Because we have 2 translations. Okay, would you turn to your neighbor and give them the 8 words, because there's 4 words for one translation, 4 words for the other translation. Turn to your neighbor and give them the 8 words. Talk. Oh, talk a little. Yeah, that's why you have a neighbor. Either one of you know that you need to turn forward or backwards and find a neighbor to help. Okay, turn forwards and backwards. These 2, Annabelle and you 2. Okay. Come on. Do that, please. Yeah. Yeah. Okay, come back to me, please, in 3, 2, 1. Who has a neighbor who knows what it is? Okay, and Cheryl, give me 4 words to describe one of them.
Yes. Yes.
Yeah, one of them. Just give me 4 words.
Horizontal shift.
Horizontal shift right 2. Give her a thumbs up or a thumbs down. Is it good, or do we need to fix something? Okay, thanks for the 5 people who responded. Thumbs up or thumbs down. Is it good, or do we need to change something?
It's good.
It's good, because we say opposite, right? Okay. Zach, what's the other 4 words? Vertical shift up 5. Thumbs up or thumbs down? Is it good, or do we need to fix something? I think it's good. Good job, because this one's same. And when we're talking vertically, your only options are up and down. Okay? So those are the descriptions of the translations. All right, example 3. Now I'm going to give you the descriptions, and you have to write we're going to do it reverse. I'm going to give you what's in the box, and you have to write the equation with those translations.
Yeah, it's gonna be fun.
It is going to be fun. Math is fun. I enjoy it. No. Okay. Right, but we're doing it for multiple parent functions. Write an equation. For each translation. We're going to be doing it twice. We're going to be doing it for the quadratic and the absolute value parent functions. Hey.
Just the person guys sent, so when the internet's down, we have
Oh,
access to the...
cool.
Yeah.
Am I just supposed to copy this to my computer?
No,
And
they're
get-
yours to keep.
Oh, we
By
each
the
got
way-
our own?
Yeah, by the way, those are last year's, numbered last year's chapters.
Oh, great.
There you go.
So thank you. Yeah. Okay. HS, horizontal shift. Okay, we're going to do this first one together, and then I'm going to give you one to try. Horizontal shift, right 5. I want you to do it for both the quadratic and the absolute value. Come on. Y equals. I'll put it over here. I need this stuff for different class, so I don't want to erase it. But remember, the A is the multiplier. Inside the function is your horizontal shift. Outside the function is your vertical shift. Opposite, same. So do we have an A? Well, technically we do. It's just 1. So we don't need to write it. Then we have an X, horizontal shift right 5. Does the 5 go... Guys, I really don't like having to talk over you.
Guys, be quiet.
Does the right go inside the function or outside the function? It's inside, but because it's inside the function, it's a 5, right 5, we would write subtract 5. Squared, that's the quadratic. Now we're also going to do the absolute value version. Is it any different? The only difference is those curvy parentheses are straight. And there's no squared, correct. There's also that difference. Okay? So I'm going to give you one to do. After you've done it, check with your neighbor, see if you did the same. And what you're doing is you're writing both equations with their translation. Vertical shift down 3. Would you insert that into the quadratic and the absolute value, please? Vertical shift down 3. Write the equation containing the translation for both the quadratic and the absolute value. That shows vertical shift down 3. And then once you've done it, check with your neighbor. Yeah?
That looks so messed up.
No, B is just B. So this is only as a vertical shift. Yep, squared. You need a squared. Also do the absolute value. Okay, Cheryl, I picked on you last. Would you pick on someone that's not Annabelle and have them go up to the board and write both of them, please? Here's the markers. Yeah.
It's not my fault. No, I thought she was going to be like, how is it my fault?
Okay, do it over on the right underneath my other quadratic and absolute value. Okay, on the quadratic, thumbs up or thumbs down? It's good, or we need to fix something? Was there a horizontal shift on this one? No, so no need for the h, because the h is 0. So x minus 0 is just x. So just erase the minus h, and then I think it's good, isn't it? And put your squared back on there. Now thumbs up? Yeah? Okay, what about her absolute value one? Thumbs up or thumbs down? Good. Yeah, those look great. Thanks. I'll let you pick the next person. Okay, I'm going to give you one more to write the equations containing the translations. C. Horizontal shift, left 2, and vertical shift up 4. You need to do it for the quadratic and the absolute value. Horizontal shift left 2 and a vertical shift up 4. Include both in your equations.
Oh. Where's my third one?
Okay, include both on your equations. You have it, turn to your neighbor and check. And make sure you have it because Cheryl can, or not Cheryl, Lee, oh sorry,
Okay.
Lee gets to pick you, so
Yeah.
better be prepared, especially if she knows you. Okay, about 10 more seconds. Okay, Lee, who's coming up? Okay, Aaliyah. Oh, my earring just fell out. It's a heavy earring. I lost the, it's like it came unattached from my ear. No, just the thingy fell apart. Anyone have pliers with them? I need to fix this. Okay, the pliers. Okay, everyone, let's look at the quadratic first. Okay, the one on the left, thumbs up. That's good. Or thumbs down, we need to fix something. So good. Left 2, up 4. Thumbs up, thumbs down. I'm gonna go with thumbs down. I see a couple. I see a detail or two you need to fix. First of all, I don't think it's quadratic. What's missing to make it quadratic? Yeah, there we go. Now is it good? Almost. Look very carefully. Left 2. Is she supposed to put +2 to go left? Yeah, because that's opposite. And vertical shift up 4. Is that -4? Ah, there we go, because it's same. Good. Okay, so you'll probably have to do that same detail over on the right, right? Because they should almost look the same. And then I think your absolute value is good. Okay, thank you. Any questions on, given the translation, writing the equation? You still have to do opposite, same. Okay, now we're going to add in the transformation. Transformation is what the A does. So the shifting is called a translation. Everyone say translation. Translation. Shifting, translation. Transformation is what the A does. Okay, so example 4. Write an equation, which we were just practicing, for each transformation of, now I'm going to add in the linear, y equals x, y equals x squared, and y equals absolute value x. We're going to do all 3. How come we can't see that? Bring your glasses. Then it sounds like you need a new prescription. Okay. Write an equation for each transformation. So the transformation I want for the first one, remember we're going to do this 3 times because I want all 3 parent functions done, is a vertical stretch by a factor of 4. Vertical stretch by a factor of 4. And you should have at the beginning of your notes what a vertical stretch looks like. When on A, we listed 3 things for A. What has to be required of A for it to be a vertical stretch? Greater than 1, or the absolute value of it is greater than 1. Is 4 greater than 1? Yeah, 4 is greater than 1. Okay? Where does the 4 go if it's a vertical stretch? Right after y equals, it's a multiplier. So this would look like y equals 4x. The quadratic would be y equals, what do you think? 4x squared. And the absolute value would be y equals 4 absolute value x. Because the vertical stretches are just a multiplier, so it just multiplies in the front. Okay? And B. I'm going to do it again. This time I want a vertical compression by a factor of 1/3. Vertical compression by a factor of 1/3. I think you can do it. Do it for all 3, please. Vertical compression by a factor of 1/3. Yeah? Yeah. Okay, who was up here last? It was Lee. Lee, pick a boy because we've had only girls go up. To come write the 3 vertical compressions by a factor of 1/3. Oh, Aaliyah, that's right. Sorry. Or point to a boy if you don't know his name, and I'll tell you what his name is. Isaac. We have 2 Isaacs, actually. I'm pretty sure you mean Nielsen, because you look that way. But Sherman's also available. Okay, Nielsen, you're up. Okay, hustle. Give it your best shot, then. Really? No. Y equals X. Where would the 1/3 go? After the Y equals. Y equals 1 X. That's the first one. Now do the quadratic. Yep. Put a comma between those 2. Thank you. Great. And the absolute value.
That's correct. That's your math question. Right?
Okay.
Very good.
And a comma.
Right?
And box them up. Thank you.
I have 10 fishes. 5 drowns.
Fishes? I don't think that's a word, though. Fishes? Fish is already plural.
Fish. 5 drowned.
Mm-hmm.
Come back to life. How much do I have?
You have 10 fish, 5 drown, but they don't drown because they're fish.
What did come back to life?
But they don't drown because they're fish. Are the ones that drown ones you don't already have? I don't think you have enough details in this. Yeah, you still have 10. Okay. Okay, so all of this so far has been review. Okay, turn around, please. Turn around, Brooklyn. Turn around.
I love them.
Okay. Turn around, please. Brooklyn.
But I'm talking to her about finning, and I think that's a really important subject on a second basis.
Okay, all we have to do... I don't know what you're talking about, but talk about it later.
I boxed them up.
Thank you.
That's right.
Guys, notice when we have a transformation, vertical stretch or compression, all you have to do is stick it in the front, right? And multiply it. Those are easy. Okay? And the negative, if we throw in a negative, that flips the graph. Do you know the word for flipping? If shifting is a translation, this multiplier is a transformation. What happens if you flip? Reflection. But you're close. Reflection. So this is half new and half, we've already know how to do this one. I told you there'd be one detail that's new. Okay? So we're going to look at reflections, but there's 2 different ways we can reflect. Okay, reflections about the x-axis and reflections about the y-axis. So if you reflect about the x-axis, you're doing a vertical flip. You're either flip-flopping down or up. If you are reflecting around the y-axis, you're going horizontally. Okay, so here's the new part. If we are to rewrite an equation that's been reflected about the x-axis or about the y-axis, something happens to the function. About the f-axis, the x becomes negative. But when you flip it about the y-axis, not just the x, the entire function becomes negative. Okay? So my new function, I'm going to use these letters in the example, so I'll label that H and this one G. If you reflect about the x-axis, the x becomes negative. If you reflect around the y-axis, the entire function sign changes. That's the new stuff for today. So for example 5, we're going to use those. Example 5. Let h of x be the reflection of f of x equals 3x plus 3 on the x-axis. What is the function of h of x? The function of h of x. Let h of x be the reflection of f of x on f of x equals 3x plus 3 on the x-axis. What is the new function? And we're calling that new function h of x. So if we're going about, oops, I missed an x. If we're going about the x-axis, only the x changes sign. Okay, so this becomes f of negative x. So wherever there's an x, what do I do with the x? I insert negative x. But these are multiplying, so you have to be careful. I insert, so I'm going to put parentheses when I'm inserting a negative x plus 3. Yeah? Because when we put in a negative x, it becomes negative 3x. And see how it's negative? The slope is negative. That means it flips. Okay? So, and we're going to call this new function h of x. Okay, so when you're rotating around the x-axis, you just insert in negative x, where the x used to be, and it flips it. That would be the new function. It's different, though, when you're rotating around the y-axis. The entire function changes sign when you rotate around the y-axis. Okay, example 6 is going to be the same type of question, except for we're going to call it g of x. Let g of x be the reflection of f of x, same function, equals 3x plus 3 on the, this time, y-axis. Same question, what is the function of g of x? If you reflect around the y-axis, everything has to change signs. So it's no longer f, it's going to be negative f of x. If everything changes signs, does it just mean the 3x is the only thing that changes signs?
No.
What about the 3? Does that change signs as well? Yeah, so to show that we do negative and put parentheses or brackets of the entire function, and then we use the distributive property. If you distribute that in, then we would see we get a negative 3x, so that's a new sign, and a negative 3, so both change signs. And this is going to be called g of x. Do you all have your calculators? We're going to see why this works on the graph. Fair now? Nope. Okay, open up your graphing calculators, please. If you don't have one, come get one. This camera. Clear out stuff that's on there. Hopefully my camera will come up soon. Go to y equals. Clear anything out that's in there. Everyone should have their graphing calculator open. Okay, let's put in the original function. Wasn't the original 3x plus 3? Okay. And arrow down. When we reflected around the x-axis, it changed to negative 3x plus 3. And I'm going to come over here to the far left side. If you arrow over to the left and get on that line, and I hit enter, I can change it so it's a thick line. See how this one's thick so I can see the difference? Arrow over and you just push enter until you get a thick line. To make sure everyone's windows are the same thing, go to Zoom and pick Z Standard. I think it's number 6, I don't know. Okay, go to Zoom, Z Standard, yep, number 6. Okay, so the thick line's the new line. Did it flip like we expected? First it was going up and now it's going down, so yes. Okay, so that's a flip around the x-axis. Now go back to y equals. On the y2, I'm going to change this to our second one. Actually, I lied. I'm not going to change it. I'm going to make a new one, y3. Negative 3x minus 3. Okay, let's see if we have another line besides. Do we have like a dotted line maybe?
Yeah.
Oh, there's a dot. I'm going to make my third one dotted so I see the differences. If I go to graph, there's the original. Here's the one that was flipped around the x. Here's the one that was flipped around the y. So this line was just turned like this, flipped around the y. Okay?
Why are there so many lines?
Because we did 3 lines. Okay. I don't think we're going to hit the exponentials today, even though it was just like one example, but I think that's plenty.